Hi everyone, my name is Mohammed Jallo, and I'm a current online Masters in Health Informatics student at the George Mason University. This is one of my Teach One module presentation for HAP 671, which is Health Database, Module 7, and we'll be talking about Predictive Model. This course is convened by Professor Abdul Hafiz and Sanya Abramovich. Our main aim in this presentation is to show the importance of predictive modeling in healthcare delivery and use this week's Module 7 assignment questions to run SQL queries and answer the first three questions, and which ask us to set aside 80% of the data from the DBO.final database as training data set, and also 20% as the validation data set. And then we are also going to do the likelihood ratio calculations, and also after that, select the top 4 highest likelihood ratios and scan the web for what those top 4 diagnoses might be. We're also going to show how we're going to use Laplace smoothing technique in likelihood ratio calculations to make sure that we have the right result. And at the end of the day, we're also going to summarize the presentation and key takeaway. Why do we even bother to do predictive modeling in healthcare? But it's predictive modeling is a standard tool across several industries, and healthcare is no exception. And from the slide, you can see that it's very useful in early disease detection and prevention, optimizing resource allocation, personalized treatment plans, and reducing readmission rates, fraud detection, and cost control. We did see in our earlier modules how we were able to clean the data and see data discrepancies in our earlier example of diabetic patient admissions and death. And you can also be able to risk stratify patient with certain disease conditions and see the burden of disease in your hospitals or in your clinic, and then see where your healthcare resources is going, and then which patient needs the greatest allocation. You can also review historical records and be able to predict seasonally when certain disease conditions are going to be prevalent, and you'll be able to allocate financial resource, health resource, or human resource during those specific times. And thorough analysis, prediction-wise, will help you be able to have a lean healthcare management. In our first question, we've been asked to randomly set aside 80% of the data for training and 20% for validation. And so in order for us to do this, we're going to be using our previous DBO.final database, which we've already cleaned. And you should be able to get it from HAP 671. So the code to use on the left-hand side, you can see is, let me see, use HAP 671, and then we're going to create a view or temporary table for training data 80%. So you can see if you use this code and create view, and then name it as training data, and then select all rows or columns from that data set from the DBO final, and then use the rand function, and then use the Boolean operator of less than or equal to 0.8, meaning that you're dealing with the 80% of the data. You should be able to see that result on the right-hand side here. And for me to be able to print it out, I was able to just select the top 10 rows from the training data set. And if you do that, you should be able to see it. And then if you come here, you can see on the system views of HAP 671, you can see the DBO training data and also the DBO validation data. So for the DBO validation data, it's kind of similar. You're also going to create view, and then from the DBO.final, use the run function. But instead of using the less than or equal to, you're going to be using the greater than Boolean operator of 0.8, meaning greater than 80%, which in which case you're referring to the 20%. So that should be able to help you answer the first question of setting 80% of the data set for training and then 20% of the data for validation. So the 20% validation is what you'll use eventually in your ROC, receiver operating curve, to see whether your calculations or predictive models are true, or they are good, or they are not good. You might also be asking, what is a create view? A view is a virtual table that is created based on the result set of an SQL statement. It contains rows and columns just like in a real table. The fields in a view are from one or more real tables in the database. So it's in other words, just a temporary table, or virtual table, sorry, that is created. Yeah, another function that we've seen from this question is the rand function. The rand function is able to generate some mathematical formula or function in SQL that generates a pseudo random float or value between 0 and 1. And if it's seeded, it normally returns a different random number each call. If it's not seeded, without a seed, sorry, it returns a different random number each call. With a seed, it returns a repeatable sequence of random set numbers. So you can use the rand function with a seed or without a seed. That is with specific patterns on it. Before going to do the second question, we need to understand what is Laplace smoothing in SQL, because without that, we might run into problems when we are calculating our likelihood ratio. So the standard formula without smoothing of the Laplace to calculate likelihood ratio is using the dead count upon the total dead divided by the alive count upon the total alive. So this is the formula for the likelihood ratio. But with the Laplace smoothing, you add 1 to each one of these calculations, like dead count plus 1, total dead plus 1, as the case may be, and then just to make sure that you don't get into issues when you doing the calculations, because certain times when you're doing likelihood ratios, you might encounter certain data set like deceased or living patient count, which are 0, or dead count, which are 0. And then if you do divisions on them, you might have errors, or you might also have issues with infinite ratios when the dead count is greater than 0, but the alive count is 0. So in other words, the Laplace smoothing is a technique used in SQL to handle 0 count scenarios when calculating probabilities or ratios. It's especially important for likelihood ratio calculations where you might divide by 0. So you might also be wondering, why did we use plus 1? Well, according to the Laplace smoothing, it helps in building predictive models. It prevents division by 0 errors, working with sparse data. It avoids infinite 0 likelihood ratios. It provides more conservative estimates for real codes, and it maintains relative ordering of probabilities. Well, having seen how we use Laplace, then we should be ready to calculate the likelihood ratio in our question 2. In doing our second question, which is calculating the likelihood ratio, you can see the formula here. In other words, likelihood ratio pretty much is you calculating the number of dead upon the total number of alive. So you have 4 parameters that you're trying to code for in SQL before you can make the calculations. So if you briefly look at the both slides on the left and right hand side, you can see so many familiar concepts like using the alias function, using the case when function, using the not null, using our aggregate function of sum count, and all of that. We also use the null if function, use the cross join, and case when, and order by and all of that. These are all concepts that we've learned before, so we just pull in everything to make the final diagnosis. So how do we go about doing this? Is through a 4-step process, but mind you, there are different ways in which you can come to the same conclusion. So by all means, feel free to use whichever SQL code is comfortable by you. But based on my research, I was able to come up with these queries, and they worked for me. So um, I use a 4-step formula. We are in the 4 steps formula. The first step is having an alias of patient status, and then selecting the ID of the patient, and then case when the age at death is not null. It's not pretty much it's not 0, then 1, else it's 0, and as is deceased from the training data. And then you use the another alias function, which is population totals. Use the aggregate function to sum is deceased, which you've calculated in the first step, and then you label that as total deceased, and then you count all the rows. You subtract that from the sum is deceased, and then you label that as total living from the patient status. And then the third step is pretty much you want to calculate the mortality by ICD-9 code, because it's the numerator in the likelihood calculation. So you have to have that. And how do you do that? You say diagnosis code, you alias that, and then you select the ICD-9 codes from the training data set. You sum it. Patient status is deceased as disease count, and then you count that just like the formula in the second step. You do the same thing, and from the training data set, and then you join it through their common column name, which is ID. So the training data set's ID, you join that with the patient status ID, which you've already calculated, and then group that by the training ICD-9, and then you next you calculate the likelihood ratio with Laplace smoothing technique, in which you use the diagnosis count of the ICD-9 code, diagnosis count of disease count, which you've already calculated, diagnosis count of the living count, and then you apply the Laplace formula to it. But the numerator, which is the number of alive by ICD upon total number of alive, you have to use the null if function. Why do we use the null if function? It helps to handle divisions by 0. If no alive patients have a particular ICD code, you can use null if to avoid division errors. And so that is one of the reasons why we use it. And then finally, we use the cross join function to calculate the data. Why do we use it in likelihood ratio calculation? It helps to make the population totals available for every ICD code calculation without filtering or limiting the results. It ensures every ICD code in diagnosis count gets paired with the population total. And without it, we lose codes that don't match specific mortality cases. So that is the reason why we use it. And the final step is using the case function, and then you can just follow it and trying to predict the likelihood ratio based on how strong the mortality predictor is, whether it's a strong predictor or moderate predictor or weak predictor based on the number above 1. And you can see on the next slide how these case labeling helps in our results section. So if you follow this code, SQL code, you should be able to calculate the likelihood ratio. Slide, you can see the result of the likelihood ratio result or calculation that we've done. In the, this is the results section. So you can see the top 4 ICD diagnosis codes and their likelihood ratios, which are pretty much in the 1,000. and how that relates to their clinical significance. So for the first one, you can see I746, likelihood ratio, the number. You can see that it's exclusive to the deceased, and it has a strong mortality predictor. So in answering the third question, the third and final question for this presentation is to calculate the top 4 likelihood ratio and then find what those diagnoses are based on the ICD code. So it's the same thing like in question 2. All the codes are very similar. You can see for yourself, very similar. Yeah, the only thing that is different is the final result section here. Let me show you here. So you can see this one here, final result. In Microsoft SQL Server, you have to select the top 4, and then when you do that, you select the ICD-9 diagnosis code. You use the round function, and then use the aliases and case function, and then you should be able to use all these codes to generate your top 4 likely ratios based on diagnosis. So let me go to the next one. So you can see here on the left hand side the top 4 ICD diagnosis codes and what their likelihood ratios are. And upon web search, I was able to see that I7 4.60 refers to mainly about embolism, thromboembolism of unspecified arteries, either of the extremities or unspecified extremity. The next one is chronic venous insufficiency, can be peripheral, which is I87.2. The next one is I20.8, which is mainly talking about angina pectoris. And then the fourth one is I80.26, which is thrombophlebitis of the popliteal vein. So you can see that the top 4 likelihood ratios are mainly relating to cardiovascular disease condition. To recap, we can see that in this presentation, we are able to talk about the importance of predictive modeling in healthcare briefly. We are also we are able to create the view function in our DBO database for the training data and the validation data set. We also see how we need to use the Laplace modeling technique to ensure that we have the right result during likelihood calculations to deal with certain zeros or certain data sets. And we did calculate the likelihood ratios using Laplace modeling. We also calculated the top 4 likelihood ratios. This far, thank you so much. I'm not the best at SQL databases. I'm still learning. So forgive me if some of the codes I didn't explain that well. I'm still learning. I'm new to this. So thank you so much. If you have any question, this is my GMU email that you can find me at, and these are the references that I was able to use and learn from, and I believe we can work it together. Good luck in the rest of your course and for this course. Thank you. Bye-bye.